Okay, so in this review, we're going to continue talking about rationalizing the denominator. The difference between this problem and the problems we did previously was notice that in this problem you have two terms. You have a 2 and then you have minus square root of 5. Subtract the square root of 5, right? So you have two terms. So to rationalize the denominator when you have two terms, you're going to use what's called the conjugate. And so we are dealing with square roots. So let me just kind of mention this. So the conjugate of, and in general, if you have a plus the square root of b, the conjugate of a plus the square root of b is, and all you do is you're going to change that middle sign here. So it'll be a minus the square root of b. So the conjugate of a plus the square root of b is a minus the square root of b. And here's the idea. So if you multiply these two binomials together, these two conjugates together, the square roots will I'm going to use the word disappear. They're no longer going to be there. You will not have a square root anymore. Okay? So that's the idea. So you're going to use the conjugate. So so let's talk about this then. I'm going to rewrite this over. So you have 3 divided by 2 minus the square root of 5. So the conjugate of 2 minus the square root of 5, so just remember you got to deal with the conjugate, Conjugate. Conjugate of 2 minus the square root of 5 is 2 plus the square root of 5. Okay? So we're going to multiply both numerator and denominator by the conjugate. That's what you have to do. All right, now we're gonna write this. See how you have two fractions being multiplied together? We're gonna write it as one fraction. So look, you have you have one term right here, right? Times two terms. So let's do it like this. You're gonna say 3 times 2 plus the square root of 5 divided by, and then put this in parentheses. Put those two in parentheses. You have 2 minus the square root of 5 times 2 plus the square root of 5. All right, so that's the first thing you have to do. So first thing, you're going to multiply both numerator and denominator by the conjugate. Notice that middle term, that middle sign changes. Okay, that's the only way. That's the only way that you would end up not having that square root in the denominator anymore is to multiply both numerator and denominator by the conjugate. Okay. All right. Now the numerator we're going to go ahead and distribute. I can use the distributive property. So that'll be 6 plus 3 square root of 5. Okay. So 3 times 2 is 6. 3 times square root of 5 is 3 square root of 5. Now let's talk about the denominator. The denominator, I'm going to use the FOIL method here. I want to show you what's going to happen. So the FOIL, remember FOIL. Let me go ahead. I'm going to go ahead and do it on here, just to kind of not use that space right here. So I'm going to rewrite this over. Just remind you FOIL. First, outer, inner, last. First times first is 2 times 2 is 4, right? The outer, you get 2 times the square root of 5 is positive 2 square root of 5. The inner, a negative square root of 5 times 2 is a negative 2 square root of 5. And then notice right away, those add up to be 0. So whenever you're dealing with conjugates, when you multiply conjugates, the outer and the inner will be opposites. So that way when you add them, they add up to be 0. All right, now be careful with the last though. You have a negative, so you last. First, outer, inner, last. The negative times a positive is a negative. The square root of 5 times the square root of 5, you know it's square root of 25, but you also know it's just what? It's just 5. And so now notice you have 4 minus 5, which is a negative 1. So that's your denominator. So this is negative 1. Now remember, you multiply this out, this is what you got, right? Okay. Now, notice though that that's just a negative 1, so you got to rewrite this better. So if the denominator is just a 1 or a negative 1, you want to rewrite it to where it's just not listed as a fraction. So here's what I want you to think about. 6 divided by negative 1 is a negative 6. 3 square root of 5 divided by negative 1 is a negative 3 square root of 5. And there's your answer. Okay? All right, so that's number 1. Let's look at number 2. Number 2, you have the square root of 5 divided by the square root of 3 plus 2. All right. Now, technically, when you talk about conjugates, when we talk about conjugates, let me find that page. So when we talk about conjugates, it's written in the form, the binomial with the square root is written in the form a plus the square root of b. So the conjugate is basically you're changing the sign of that square root. It's not written in that order though, and it's okay if what most students do, and it still works. What most students do is they'll even though the square root of 3 is listed first, they'll just change the sign, and that's fine. So it'll still work out. So you get the square root of 5 divided by the square root of 3 plus 2. Someone else could have written it as 2 plus the square root of 3, right? Does not matter. Does not matter. If you multiply both numerator and denominator by the conjugate, you want to get rid of that square root. Remember, you want to rationalize the denominator. And I forgot to mention, see this denominator is now a rational number. You no longer have a square root. So to get rid of that square root, you're going to multiply both numerator and the denominator by the conjugate. The conjugate of the square root of 3 plus 2, you're going to write as almost all students will write as the square root of 3 minus 2. Okay? And that will work. That will get rid of that square root that's in the denominator. Now, just like we did previously, let's go ahead and rewrite this as the square root of 5 times the square root of 3 minus 2, just like this, divided by, and then the square root of 3 plus 2 times the square root of 3 minus 2. Okay? All right. Now let's distribute the numerator. Now you got to remember some properties. The square root of 5 times the square root of 3 is the square root of 15. Minus, and then the square root of 5 times 2 is 2 square root of 5. See, those two, the radicals were the same, so you multiply the radicands together. Now let's go ahead and do the work with this one. So let me go ahead and do that here. So I'm going to rewrite this over just to show you what you're going to deal with using FOIL. So square root of 3 plus 2, square root of 3 minus 2. All right, first times first. Square root of 3 times square root of 3 is 3. The outer, and remember, those are conjugates, right? So the outer and the inner better add up to be 0. They better be opposites, and they will. Watch. The square root of 3 times the negative 2 is negative 2 square root of 3. The inner is a positive 2 square root of 3. See, those are opposites. You get when you add them up, you get 0. A positive 2 times a negative 2 is a negative 4. And so 3 subtract 4 is a negative 1. So I get a negative 1 again. I didn't mean for that to happen, but that's what happened here. So I get negative 1. So that's the numerator. I'm sorry, the denominator. So notice it's a rational number. So since that's a negative 1, so whenever it's 1 and negative 1, rewrite it so that way you don't have that denominator anymore. So square root of 15 divided by negative 1 is negative square root of 15. Negative 2 square root of 5 divided by negative 1, and negative divided by negative is a positive, so it's positive 2 square root of 5. And so that's it. There's your answer. Okay? That's the answer. The denominator is now a positive 1. Let me go ahead and do another one, and so that way we don't get a negative 1, just to show you how you're going to write it. So let's put this as number 3. So let's say we had, let me do another square root in the numerator, so that way you can remember how to deal with this. Square root of 6 divided by, and let's say this is square root of 5. Let's do it this way. I'm sorry. Square root of 6 divided by 3 minus the square root of 7. 3 minus the square root of 7. Okay, so the conjugate of 3 minus the square root of 7 is 3 plus the square root of 7, right? So you can multiply both numerator and denominator by 3 plus the square root of 7, just like this. Okay, so rewriting this as one fraction, you're going to get the square root of 6 times 3 plus the square root of 7 divided by 3 minus the square root of 7 times 3 plus the square root of 7, right? Okay. So let's distribute the square root of 6 here. So I get square root of 6 times 3 is 3 square root of 6. The square root of 6 times the square root of 7 is the square root of 42, right? Divided by, now we're going to FOIL this out. I'm going to actually put the work here. We're going to FOIL this out. 3 times 3 is 9. The outer and the inner, now you all know that that's 0, right? The outer is, you see that's a 3 square root of 7, and the inner is a negative 3 square root of 7. Since those are conjugates, the outer and inner will add it to be 0. So you don't have to write it. It has to be 0. So leave it off. But you do have the last now. A negative times a positive is a negative, and the square root of 7 times the square root of 7 is 7. And now notice my denominator is now 2. So you get 3 square root of 6 plus the square root of 42 divided by 2. And then also the square root of 42 you cannot simplify. The square root of 6 you cannot simplify. So there's your answer. Okay? So notice that the denominator is a rational number. Okay, that was number 3. Let's look at number 4. Okay, number 4, let's suppose we had this in number 4. All right, number 4. We have let's say 7 divided by 4 plus the square root of 3x. All right, don't let that throw you off the fact that you have an x here in the radicand. So you want to rationalize the denominators, meaning that you want to get rid of that square root that's in the denominator. You want to get rid of that radical. So since this is two terms, think of this as a binomial. Since this is a binomial, you're going to use the conjugate. So I'm going to go ahead and rewrite this over. That's 3x. So you'll multiply both numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator is 4 minus the square root of 3x. Okay? You multiply both numerator and denominator by that. And so now you have one term times two terms. So you're going to say 7 times 4 minus the square root of 3x divided by, and then this times this. So write it like this. 4 plus the square root of 3x times 4 minus the square root of 3x, right? Okay. Now let's get rid of the parentheses in the numerator. To do that, you can distribute. 7 times 4 is 28. 7 times a negative square root of 3x is a negative 7 square root of 3x. Divided by, all right, let's do the work here. We're going to use FOIL. 4 times 4 is 16. The outer and the inner, the outer is a negative 4 square root of 3x. The inner is a positive 4 square root of 3x. That has to be 0. Now look at the last. A positive times a negative is a negative. The square root of 3x times the square root of 3x is just what? Real quick, what do you think it is? Real quick, 3x, right? And then some of you may say, well, how did you get that? Well, remember the square root of 3x times the square root of 3x, right? So you're multiplying two square roots, two radicals with the same index. So 3 times 3 is 9. So the square root of 9, x times x is x squared. And what's the square root of 9? The square root of 9 is 3. What's the square root of x squared? X. And those are not like terms, so that's all you can do. There's your answer. And you did rationalize the denominator because you see you don't have a square root in the denominator anymore, right? So you're done. That's it. All right, let's look at another one. So in number 5, let's say you had the square root of 7 divided by the square root of 3 minus the square root of 7. All right, so now we have two terms with square roots. That's okay. We can handle that. So we're going to use the conjugate. So I have the square root of 7. I'm just going to go ahead and rewrite this over. Okay, the conjugate of the denominator is the square root of 3 plus the square root of, that's supposed to be 7. The square root of 3 plus the square root of 7. That's a 7 right here. Square root of 3 plus the square root of 7. Okay, now let's go ahead and write this as one fraction. So you're going to say the square root of 7 times this binomial, square root of 3 plus square root of 7, divided by, and then we're going to multiply these two together. So square root of 3 minus square root of 7 times square root of 3 plus the square root of 7. Very simple process, not difficult at all. Distribute. The square root of 7 times the square root of 3 is the square root of 21, right? The indices are the same. You multiply the radicands. The square root of 7 times the square root of 7 is just what? 7. Don't say the square root of 49. If you do, you have to simplify that. It's just 7, right? Divided by, all right, now let's FOIL this. The square root of 3 times the square root of 3. Let me go ahead and write it out right here. Square root of 3, minus square root of 7 times the square root of 3 plus the square root of 7. First times first. Square root of 3 times the square root of 3 is what? 3. The outer. the square root of 3 times the square root of 7. Hopefully you all know by now that the outer and the inner will add up to be 0, right? Okay. And so you can skip that part. But if you do, write it, keep in mind what you have. You have the square root of 3 times the square root of 7 is the square root of 21. The inner, a negative 7 times the square root of 3 is a negative square root of 21. And notice those two terms are opposites. So when you add them up, you get 0. All right, now be careful for the next one. With the last, a negative times a positive is a negative. The square root of 7 times the square root of 7 is 7. So you get 3 minus 7 is a negative 4. Okay? So this becomes negative 4 down here. And you can leave your answer like that. It's okay to have that denominator negative. That nothing's wrong with that. And notice that this is a rational number. So you went from a denominator with 2 square roots to none. Okay? But I just want to say this though. It is possible that if this were multiple choice that this would not be the answer you would see. So here's what could happen. So I just want to show you this. So you see that negative down here, the negative symbol. Do y'all agree that that's the same thing as saying this? The square root is 21 plus 7 divided by 4. So the opposite of this is the same thing as that, right? Okay. Or you could have, instead of having the square root of 21 listed first, it could have been listed second. So you could have said this, 7 plus the square root of 21 divided by 4. Or you could have had this instead. So instead of the negative being down here, you could have had it in the numerator. So a positive divided by negative is a negative. A positive divided by negative is a negative. So you could have had this. Negative square root of 21 minus the square root of 7 divided by 4. So the point being that all of these are the same. Oh, I did not mean this to be 7. That's 7, right? Not square root of 7, but 7. So the point being that all of these are equivalent. All right, but most students, they'll leave it like this, and that's fine. You're fine. Just make sure, if it's multiple choice, that you're able to recognize that these are the same as this. Okay, let's look at another one. Let's do a couple more. So it's not difficult. You're dealing with conjugates this time. Okay, so let's look at number 6. We have negative 2 divided by 4 plus the square root of 3. Negative 2 divided by 4 plus the square root of 3. All right, so the conjugate, you have two terms in the denominator. So the conjugate of 4 plus the square root of 3 is 4 minus the square root of 3. So you can multiply both numerator and denominator by 4 minus the square root of 3. And so we're going to multiply the numerators and denominators. And so I get negative 2 times 4 minus the square root of 3. And the denominator you have 4 plus the square root of 3 times 4 minus the square root of 3. Okay? All right, so let's distribute. Negative 2 times 4 is a negative 8. A negative 2 times a negative square root of 3 is a positive 2 square root of 3. Okay? All right. Denominator. FOIL. 4 times 4 is 16. The outer and the inner will add up to be 0 because those are conjugates. The last. A positive square root of 3 times a negative square root of 3 is a negative 3. So you get negative 8 plus 2 square root of 3 divided by, and then 16 minus 3 is 13. And there's your answer. Okay? All right, number 7. Number 7, let's suppose we had this in number 7. So let's do another one where you had 2 square roots in the denominator. So this is number 7. You have 8 divided by the square root of 15 minus the square root of 5. All right, so let's go ahead and rationalize the denominator. But since I have 2 terms, I need to use the conjugate. So 8 divided by the square root of 15 minus the square root of 5. So I'm going to multiply both numerator and denominator by the conjugate, which is the square root of 15 plus the square root of 5, right? This sign changes in the middle. Square root of 15 plus the square root of 5. All right. Now I have one term times 2. So remember how to write this. You're going to say 8 times square root of 15 plus square root of 5 divided by, and then these two binomials multiplied together. Remember, those are conjugates. Those are conjugates. So that means that when you FOIL, the outer and the inner are going to add up to be 0. So use that fact. Okay, so in the numerator, distributing, I get 8 square root of 15 plus 8 square root of 5, right? Divided by, all right, now those are conjugates. So the outer and the inner will add up to be 0. So let's just look at the first and last. The square root of 15 times the square root of 15 is 15. A negative square root of 5 times a positive square root of 5 is a negative 5. Okay? So I get 8 square root of 15 plus 8 square root of 5 divided by, and then 15 minus 5 is 10. Okay, now, if you leave your answer like this, I will give you full points. But I want you to notice though, technically, you can reduce this. See this 8? I can factor out an 8. See that 8 right here before I distribute it? That 8 reduces into this 10. So let's go ahead and do that. So I get 8 times the square root of 15 plus the square root of 5 divided by 10, and then reduce the 8 tenths. So they're both divisible by 2, so that's 4 and that's 5, right? So I get 4, and then now distribute, you get 4 square root of 15 plus 4 square root of 5 divided by 5. And you could have done that here. 8, 8, and 10, they're all divisible by 2, so they'll be 4, 4, and 5. That's what you have here. All right? Okay, and then number 8. So let's say we had this in number 8. So you could see this. So you have 2 minus the square root of 5 divided by 3 plus the square root of 7. In all the problems we've done, the previous 7 problems, notice that the numerator had 1 term. The denominator had 2. This is the first situation where the numerator and the denominator have 2. No big deal. You can handle this. You're still going to use the conjugate of the denominator. So, oh, and by the way, you remember you're rationalizing the denominator, right? So it's okay for the numerator to have square roots. You don't want the denominator to have square roots. So that's why the directions said rationalize the denominator. So you want the denominator to be rational. So it's okay for the numerator to have radicals. Is the denominator you don't want to have radicals. Okay? Okay, so I want to get rid of that square root that's in the denominator. It's okay for the numerator to have it. I don't want the denominator to have it. So that's why it says rationalize the denominator. So we're going to use a conjugate of the denominator. So let me go ahead and write this over. And so the conjugate of 3 plus the square root of 7 is 3 minus the square root of 7. Just like that. And so now you're going to notice this time. So remember in all the previous problems, you said this times this numerator, so you distributed, right? Because you had 1 term times 2, a monomial times a binomial. Here you have 2 binomials, so you have to FOIL in both cases. Okay, so you got to be careful. So you have 2 minus the square root of 5 times 3 minus the square root of 7. That's the numerator. The denominator is 3 plus the square root of 7 times 3 minus the square root of 7. All right, now be careful. It is true that for the denominator, since those are conjugates, the outer and the inner will add up to be 0. That's only true because there's conjugates, right? The numerator are not conjugates, so you actually have to do that work. So you got to be careful. So watch. Let me go ahead and write the numerator out here. 2 minus the square root of 5 times 3 minus the square root of 7. Those are not conjugates, so you better do FOIL, first, outer, inner, last. 2 times 3 is 6. The outer 2 times the negative square root of 7 is a negative 2 square root of 7. The inner, a negative square root of 5 times 3 is a negative 3 square root of 5. And then the last, a negative square root of 5 times a negative square root of 7. A negative times a negative is a positive. The square root of 5 times square root of 7 is the square root of 35. And all these terms are not like terms. No terms are alike. And I cannot simplify any of those radicals. So the numerator is just this. That's the numerator. No terms are alike. They are all different. So I get 6 minus 2 square root of 7 minus 3 square root of 5 plus the square root of 35 divided by, now let's do the denominator. Those are conjugates. So 3 times 3 is 9. The outer and the inner will add up to be 0 because those are conjugates. A positive times a negative is a negative. 7 square root of 7 times square root of 7 is 7. And so I get 6 minus 2 square root of 7 minus 3 square root of 5 plus square root of 35 divided by 2. And there's your answer. Okay? That's all you do. So it's okay for the numerator to have square roots. You don't want the denominator. So that's why you don't see it in the denominator any longer, because you rationalize the denominator. Okay, let's do one more. Number 9. Number 9, I want to do this one. So you have 2 square root of x divided by the square root of x plus the square root of 7. All right? So I have square roots in the denominator. It's a binomial, so I'm going to multiply both numerator and denominator by the conjugate. So I get 2 square root of x divided by the square root of x plus the square root of 7. All right, so multiply by the conjugate. So it'll be the square root of x minus square root of 7, square root of x minus square root of 7. All right, so you have 1 times 2 two terms. So you're going to say 2 square root of x times the square root of x minus square root of 7 divided by, and then these two together. Square root of x plus square root of 7 times square root of x minus square root of 7. Distributing the numerator, I get, now remember you get square root of x and square root of x, right? So you get 2 square root of x. Here's what you have. You have 2 square root of x times square root of x. But you all know that the square root of x times square root of x is x. So that's just 2x, right? Okay. So I get 2x. Then minus, then you have 2 square root of x times square root of 7. You all know that this is 2 square root of 7x. That's what that is. So that goes here. 2 square root of 7x divided by, okay. Make sure you see that numerator, how we got this. This times this is 2x because the square root of x times square root of x is x. This times this is this because the square root of x times the square root of 7 is the square root of 7x. The denominator are conjugates. So the outer and the inner will add up to be 0. The square root of x times the square root of x is x. A positive times a negative, the last, a positive times a negative is a negative. The square root of 7 times square root of 7 is 7, and that's all you can do. Cannot reduce this at all. You cannot simplify this. You may say, well, could you factor out a 2? Sure you can. You could factor out the 2, and there's nothing wrong with that. You could say 2 times x minus the square root of 7x divided by x minus 7. But see, those are not like factors, right? See, that is the square root of 7x. This is just 7. So that's all you can do. Okay? All right. So that is rationalizing the denominator when you have 2 terms in the denominator. And so you have to use the idea of conjugate. Okay? All right, so that's the end of this review.